Hello, my name is Eric Perlad. I'm Technical Account Manager at AdaCore, in charge of the European market. Today, I'll be talking about certification and more specifically about cost-effective approach to software certification using AdaCore tools. During this presentation, you have access to the Q&A. Do not hesitate to ask any question in the chat. We will answer it after the presentation. Thank you. So to start, giving a bit of context, first, what is critical software? Software is seen as critical when its quality and dependability impact the operations and processes of any critical application, system, or mission using it. That's where failure is not an option. When critical software is deployed, as flaws can result in major damage to a business or mission, have legal and environmental implication, or lead to loss of life. Therefore, the critical software must first operate consistently with regard to the specification and requirements. It must not harm its users. Outside forces must not harm the software, of course, and it must be able to operate and be maintained over long term without requiring constant updates. A growing number of industries depend on critical software to safely fulfill their key objectives. Therefore, it's crucial to business mission, safety, and security critical systems. It has to balance reliability and security with innovation and efficiency. Now, moving to certification. First, a word about safety certification. To remind that it applies to a complete safety critical system, such as a plane, a rocket, a train, or a car, rather than to individual components. Software is only a small part of the complete certification effort, which also includes a global safety analysis, system architecture and design, and hardware consideration. That being said, the role of software in such systems has steadily and significantly grown, both in size, functionality, and complexity, making software aspect of certification more challenging and important today. The major goal of such software-related standards is to enforce the application of sound engineering principles to the development of critical software. The more critical the software, the higher the degree of confidence is needed that the software is doing what it's supposed to do and only what it's supposed to do. The major contribution that software can make to the safety of a system is to implement accurately, without exceptions, what is expected of it. Therefore, there's a tight link between critical software and software certification. Now, why do we talk about cost? Software certification is expensive. Developing critical software is expensive. Adding the certification on top of it is even more expensive due to the additional activities required by the certification standards. Standards are requesting evidence through artifacts with full traceability from requirements to test results. Here is a non-exhaustive list of the kind of activities you can expect in a certification process. And you need to have the ability to maintain them over the time, which usually is a long-term development process. Why is AdaCore talking about software certification? Again, a bit of context. AdaCore started 25 years ago with the Ada compiler. Since the beginning, it has been providing development tools to customers in the most demanding safety-critical industries. Ada has always had a strong presence in aerospace and defense, and a number of AdaCore's major customers develop software that needs to meet certification standards in this domain. AdaCore has acquired a deep familiarity with how software is certified at the highest level of criticality. We have subsequently leveraged this expertise in other safety critical domains and for other languages like C or C++. Talking about standards, which standards are today supported by AdaCore? We have qualified tools and certified software for the following. So D178 BNC for avionics, EN 5128 for railway, ECSS for space in Europe, IC 61508 for industrial automation, and ISO 26262 for the automotive market. Why would you need tools, and how to trust them, how to trust the use of the tools in your certification process? First, tools are replacing manual activities. The goal here is obviously to reduce the costs and avoid error-prone manual activities. Most certification standards are defining tool qualification. And the question is how to achieve that. As an example, I took what ISO 26262 is describing for tool qualification. You can qualify a tool in 4 different ways: by increasing confidence from use. So this method requires that a tool has already been used in a comparable project and has been on the market for many years. Or you can evaluate the tool development process. So here the user of the software tool evaluates the development process of the tool, either on its side or at the tool vendor side. You can also validate the software tool. The tool user or the vendor creates requirement-based functional tests for the use function of the software tool and execute these tests, proving that the tool is operating as expected. And finally, you can develop the tool in accordance with safety standards, where you will use the same level of criticality to develop the tool than you are using to develop the software under development by this tool. How to pick the right tool. First, a little bit about the languages. Here is a diagram showing potential reduction of development costs per device in aerospace and defense using different languages compared to C. This is an extract from a VDC study that you can find on our website. It's showing that using Ada, you can reduce by 38% the cost per device compared to C. Using Java, it's 11% reduction, and 2% for C++, 12% for C#. It is mainly explained by the responsibility split between what the language is providing. The language is a tool in itself. So what the language is assuming compared to what the developer, which is a human, is assuming. Tools are less error prone, so the more the language is doing, the less manual activities have to be performed. Moving to the software project lifecycle. So here is the usual V cycle. You can see what AdaCore tools are covering. So we are covering from model-based engineering tools to compilers, verification tools, verification also based on formal methods, and source and object coverage analysis. In more details, you can see here that languages are useful in the design phase. So by construction, the language helps you in your design. Then in the implementation, you will find the compilers, the development environment, GNAT Studio, again the languages, or Qgen, which is the code generator from Simulink model. For the testing, we have tools creating testing framework, NAT-test, emulator, coverage tool, coding standards checker, stack analysis tools, metric, dashboard, Spark tools for formal verification, and advanced static analysis tool, CodePeer. And for the integration, you can also use GNAT-test for unit testing. AdaCore is also developing the tools following a clear release cycle. Here is what is happening every year. So you can see from 2017 to 2022, sorry. You have a yearly release cycle with 2 major versions a year. When you need for certification purpose to freeze your tools, compilers and other tools, you don't want to have to migrate to newer version of the tool. You rather want to maintain the given version for the duration of the project. We, in our subscription with GNAT Pro Assurance, are providing this support for frozen version, where we extend existing branch for critical fixes over the years, as long as the subscription is active. About the runtimes, advanced language are requiring runtime support. Giving some example here, Ada requires runtime for tasking features. Ada, C++, and Java are providing exception propagation through runtime. Object-oriented programming also requires runtime for Ada, C++, and Java. And in Java, the runtime provides the garbage collection. Those runtimes are embedded in your application, so they are seen as part of the application, and they need to be certified. Latest news, we are introducing in the latest version of GNAT a new version of certifiable runtime, the light and the light tasking runtimes, which are certifiable. Now, moving to the different standards, here is a list of tools and services we are providing for D0178B and C. So you can find compiler traceability study for Ada and C, GNAT check qualification, so this is the tool checking the coding standards for your source code. GNAT coverage qualification, providing coverage analysis for Ada and C. CodePeer qualification, and work in progress on Qgen, so the code generator for Simulink and Stateflow, is being qualified for the 178 TQL1 level. For the railway now, 50128 standard, we are covering our full offering. From the language Ada 2012, Spark 2014, GNAT compiler, CodePeer again, metric, all the static analysis tool, dashboard, unit test, and dynamic analysis with emulator and GNAT coverage. For ISO 26262 and IC 61508, we have qualified GNAT Pro, the compiler, to TCL3. We have also qualified a common code generator, which is a tool compiling a subset of Ada, which is near to Spark, subset of Ada to C. You can then use your C compiler for targets on which we are not providing support with our compiler. And we have also qualified Spark Pro, so the formal verification tools for Spark TCL3 as well. For the space industry now, we have qualified our multitasking solution, which is the Ravenscar runtime. which will now be named the light tasking runtime. We have pre-qualified it with ESA, and you can use the adaptation and validation kit to use this runtime on your own project. And also, we have just released this booklet, AdaCore Technology for Space System Software, that you can find on our website. We also have other books for 5128, D0178, describing how to use our technologies for a certification project, and a book for 26262 standards is on its way. So why would you pick tools from AdaCore rather than any other vendor? First, we're providing open source software technology. So adopting our technology will allow you transparency and traceability, will give you transparency and traceability, and you will benefit from the fact that you're not locked into a single vendor. We are also providing support. With our subscription, you have access to all our experts, and we have a renewal rate of 90% in our subscription today. We are providing consulting and custom development through services, and obviously software certification for the runtimes and tool qualification for all our tools. In conclusion, AdaCore helps organizations ensure their critical software is secure, safe, reliable, and innovative. The technologies are fitting the software certification requirements. The tools are qualifiable, runtimes are certifiable. Through the support and the service, the customer can gain a competitive advantage by achieving the highest level of certification, enabling them to meet the most stringent regulatory requirements. Thank you. We will now move to the Q&A session and answer the question you have asked. Thank you for listening.